Hey everyone, and welcome back to the channel. Today, we are diving deep into one of the most talked about and futuristic technologies out there, brain-computer interfaces. Specifically focusing on the latest updates from Elon Musk's company, Neuralink. What started as a sci-fi dream is rapidly becoming a tangible reality, and the progress is both staggering and incredibly exciting. So, what exactly is Neuralink, and what's all the buzz about? Let's break it down! At its core, Neuralink is developing an implantable brain-computer interface, or BCI. Imagine a tiny device about the size of a coin that can be surgically placed in the skull. This device, called the Link, is connected to flexible threads much thinner than a human hair that are carefully inserted into the brain. These threads contain electrodes that can detect and record neural activity, the electrical signals that your brain cells, or neurons, use to communicate, but it doesn't just read signals. It can also stimulate them. This two-way communication is what makes Neuralink so revolutionary. The initial goal, and it's a profoundly important one, is to help people with paralysis. By reading the neural signals associated with the intention to move, the Link could allow someone to control a computer cursor, a smartphone, or even a prosthetic limb just by thinking about it. This could restore a level of independence and communication that was previously lost. The journey to this point has been a fascinating one. Back in 2019, Neuralink first unveiled its technology, demonstrating the concept with early prototypes. A year later, they showcased a live demonstration with a pig named Gertrude. We could see and hear her brain activity in real time as she explored her pen. A major step improving the device's ability to safely record neural data from a living, moving animal. Then, we saw Pager, a macaque, playing the video game Pong with his mind. He was initially taught to play with a joystick, but after the Link learned to associate his neural patterns with the joystick movements, the joystick was disconnected, and he continued to play seamlessly, just by thinking. This brings us to the most significant update yet. The first human trial. In early 2024, Neuralink announced that the first human patient had received the implant. This trial, named the PRIME study, which stands for Precise Robotically Implanted Brain-Computer Interface, is focused on testing the safety and initial functionality of the device for individuals with quadriplegia. The goal is to enable them to control external devices through thought. Just a few weeks after the implant, we got our first glimpse of the results. Neuralink live-streamed the demonstration featuring Noland Arbaugh, the first human recipient. Noland, who was paralyzed from the shoulders down after a diving accident, was shown playing online chess on his laptop, moving the cursor across the board with his thoughts. He described the experience as being like using the Force, simply staring at the screen and watching the cursor move where he wanted it to go. He even managed to pull an all-nighter playing the game Civilization 6, something he hadn't been able to do on his own since his accident. It was a powerful and emotional demonstration of the technology's potential to restore agency and joy. Of course, the journey wasn't without its challenges. Neuralink later reported that a number of the implanted threads had retracted from the brain tissue in the weeks following the surgery. This led to a reduction in the amount of data the device could collect. The team had to make software adjustments to improve the algorithm's sensitivity to the remaining signals, effectively regaining the device's initial performance. This transparency is crucial. Developing groundbreaking technology is never a straight line, and openly discussing these setbacks and how they are overcome is a key part of the scientific process. It shows they are learning and adapting in real time. So, how is this all possible? The surgical procedure itself is a marvel of modern robotics. Neuralink has developed a custom surgical robot designed to insert the delicate threads with incredible precision, avoiding blood vessels and minimizing tissue damage. The goal is to make the procedure as routine and safe as something like LASIK eye surgery in the future. The robot's precision is something that a human surgeon simply couldn't replicate, ensuring the threads are placed in the exact right locations to capture the intended neural signals. The device is also designed for convenience. The Link implant is cosmetically invisible after surgery and charges wirelessly. You'd simply place a small inductive charger over the implant area, perhaps while you sleep, to keep it powered. The data from the brain is transmitted wirelessly to a nearby device, like a computer or a phone, where it's decoded into commands. This seamless integration into daily life is a key aspect of their design philosophy. Looking beyond the immediate goal of helping people with paralysis, The long-term vision for Neuralink is far more ambitious. Elon Musk has often spoken about the potential for a symbiotic relationship between human and artificial intelligence. The idea is that as AI becomes increasingly powerful, a high-bandwidth BCI could serve as a bridge, allowing humans to keep pace and merge with AI. This could unlock incredible possibilities for learning, communication, and creativity. Imagine being able to download a new skill, communicate telepathically, or access vast amounts of information instantly. These long-term goals are, of course, highly speculative and raise a host of ethical questions that society will need to grapple with. Questions about privacy, security, and what it even means to be human will become central to the conversation. Who has access to this technology? How do we protect our thoughts from being hacked? What are the societal implications of a world where some people have enhanced cognitive abilities? These are not just technical challenges, but profound philosophical ones. For now, however, the focus remains firmly on the medical applications. The potential to treat a wide range of neurological disorders is immense. Beyond paralysis, researchers believe BCIs could one day help with conditions like blindness by feeding visual information directly to the visual cortex or hearing loss. It could also offer new treatments for epilepsy by detecting and stopping seizures before they happen, or help manage symptoms of Parkinson's disease, depression, and other brain-related conditions. The progress from a pig to a monkey playing Pong to a person controlling a computer with their mind is a remarkable trajectory in just a few short years. Noland Arbaugh's story is just the beginning. As more participants join the PRIME study and other trials, we will learn more about the device's capabilities and limitations. Each step forward brings us closer to a future where neurological injuries and diseases can be treated in ways we once only dreamed of. It's an exciting time to be alive, witnessing the dawn of a new era in neuroscience and technology. The road ahead is long and filled with challenges, both technical and ethical, but the potential to improve human lives is undeniable. We will be keeping a close eye on Neuralink and the entire field of brain-computer interfaces as this incredible story continues to unfold. What are your thoughts on this technology? Are you excited, concerned, or a bit of both? Let me know in the comments below. I'd love to hear your perspective. Thanks for watching, and if you found this video informative, be sure to hit that like button and subscribe for more deep dives into the tech that is shaping our future. See you in the next one!